Assalamualaikum and welcome back to my lecture. Today we're going to continue to next part, which is moment of force in 3D. Moment in 3D can be calculated by using 2D approach, but it's difficult and time consuming. Therefore, we're going to use vector cross product. What is vector cross product? For this one, you have to remember we need to identify our force in Cartesian and our position vector. As you can see here, your force in 3D, here is your F, here is our R. Therefore, by using the vector cross product, we can find our moment at O. Here in this figure, you can see we identify our R into Z-axis, X-axis, also Y-axis. Similarly, for our F, what is Fy, what is Fx, what is Fz. Then we assemble that and we can express as in this shape. So here on I, this one J, and this one is K. Then we expand this, we get our MO. How to do that? For example, we do for I, we take this out. So Ry times by Fz minus by Rz Fy. So that one for I. Next, we do for J. To do for J, we take out this column. Then Rx times by Fz minus by Rz Fx. Don't forget, this one is minus. Do the same for K. Take out this row. Then we do the operation. Rx times Fy minus Ry times Fx. So this one for K. That's how we expanding 2 times 2 determinants. Also in this note, you have to remember about right hand rule terms, and please do read this note, also this one. But what I want to highlight here about using this circle. How to use this circle? We take for this as an example. For the result I times by J, I times by J, we get K. So this one is anti-clockwise. So this one is positive K. Let's do for the others. For example, we take K times J. K times J. The result is I. That is clockwise. Therefore, is negative I. So once again, for the anti-clockwise is positive and clockwise is negative. This is how we're going to use this circle. Also, when the vector cross to itself is equal to 0, I times I equal to 0, J times J equal to 0, K times K equal to 0. Once again, for the cross products rule, we assemble in this shape. Then please find the element for I, J, and K respectively. For I, take out column on I and row on I, and the value for that is AY times BZ minus AZ BY. For J, take out the column and row, and the product for that AX times BZ minus AZ BX. For element J, don't forget the negative sign. Now for the K, take out the row and column, AX times BY minus AY BX. So that for element K. Next, let's do example 4.5. For this question, we have to determine what is the resultant moment by force F1 and F2. Here is given the force in Cartesian notation. So this is point O, this is A, so this is moment arm or D. So here is our moment arm. So we need to identify what is moment about O. F1 and F2 are given in Cartesian notation. Therefore, moment about O is position vector OA times by F. F is F1 plus F2 and ROA is position vector. Now we need to find what is the total force. So the total force F1 plus F2, find what on I. On I is 100 plus negative 200. For J, negative 120 plus 250. Then for K, 75 plus 100. So we get our F in Cartesian notation. Next, we need to identify our position vector ROA. To do that, we need to determine the coordinate for point A and O. In this case, we're going to take point O as the origin, which is 0, 0, 0. Then we need to identify what is coordinate for A. For A is 4 on X, positive. Then on Y is 5 feet. Then going up on Z is 3 feet. So the coordinate is 4, 5, 3. So when we're going to find what is the position vector ROA, that means point A minus point O. Therefore, for I, 4 minus 0 for I. For J, 5 minus 0. Then for K is 3 minus 0. Therefore, we get our position vector for ROA. Then, we need to do the cross product between F and ROA. Remember this form? So find what is on I. For ROA, 4. Then for F is negative 100. So on J, 5 on position vector. Then 130 for force. Then for K, here for K, 3 for position vector and 175 for force. So expand this, then we can get our MO. Let's do for element I. Take out for column I and row I. Then the value for that is 5 times 175 minus 3 times 130. So do the same for element J and element K. But don't forget, for element J is minus. So by doing that step, we get our MO. And always remember the unit, pound feet, because our F is pound and our position vector in feet. Do write the unit for your answer.